Alright, I'm gonna start racking on this. Um, Hopefully, as you're writing that stuff down, some of it at least sounded familiar. This, I think you can pronounce this two different ways. I pronounce it arithmetic. It's also arithmetic. I don't know if it matters one way or the other. Do you remember what case it called it? I don't know. I feel like if I'm pronouncing it arithmetic, I'm sure that that's the way he probably pronounced it because I don't know where else I would have come up with that. But it is also the same spelling as like arithmetic. So if you pronounce it as that, that's fine too. I don't care. Um, but we talked about, or you guys hopefully talked about this stuff a little bit last year in Algebra 2. So hopefully, like I said, some of it's review. So the first thing there, definition of a sequence. Sequence is a function whose domain is a set of consecutive integers greater than or equal to an integer k. Basically, a sequence is just like sets of numbers in like an order where you're like listing things out. And that's kind of where this term and position stuff comes in. So your term is your element in the range of the sequence, or like the number that gets kicked out. And a lot of times we'll represent that as like a sub, and then whatever, or it could be whatever letter there. But whatever the sub is, that would be like the position that it is in the sequence, and that's kind of this here. So it says terms domain numbers is its place in the sequence. So previously we would have called that like first term, second term, that kind of thing. Now they're just saying that another way of saying that is like position 1 and position 2. So if something's like the first term, it's in the first position. So basically like all this stuff on the top here is listing what its positions are. And then all the stuff on the bottom there is like what your actual term would be. So Fibonacci sequence is a very famous sequence. Basically how it works is, so as you're going there, you know, first term, second, third, and so on, what happens is you take the previous two numbers and add them together. So the first one's just 1 and 1, or the first one's 1, second one's 1. To get this one, you take the previous two numbers and add them. So like 1 and 1 is 2. To get the 3, they take 2 and 1, get 3. To get 5, 2 and 3 adds to 5, and so on there. So if they, you know, have any questions, it's referring to that Fibonacci sequence. That's kind of what they're talking about there. There's another one called harmonic sequence that we'll deal with. I don't know if we deal with it in tomorrow's stuff or the next day's stuff, but in the next couple days, there's another kind of like famous sequence that we'll use still. Next stuff there, so we're going to focus on two different types of formulas, explicit and recursive. They're basically both ways of writing the same types of things, just sometimes one of them is more ideal than the other. So for explicit formula, this one's easiest if you need to plug in a value of n and just kick out an answer. So if you just need one answer and not like a list of answers, and it's a fairly high one that you're looking for, you could just take that term number, plug it into your explicit formula, and kick out your term. Recursive is good when you need like a list of numbers. So like say you need like the first 10 numbers in a list or whatever, or in a sequence. That one's better for that, but realistically you can use either one to get the same answers. So today we're just going to focus on the arithmetic sequence. So this stuff here is the most important part of the lesson. So like the arithmetic, and then the explicit version and the recursive version. Tomorrow we'll do geometric, which is kind of similar concepts. So our explicit here is going to be written as your a sub n, and again that's just the term value that we're going to kick out, is equal to, this d stands for constant difference, so however much we're changing by each time is what that value is going to be, and then it's always parentheses n minus 1 plus, and then that n sub 1 is always our first term, or like the number that's in our first position. And with our arithmetic stuff, the important thing is it's always something is added or subtracted between our terms. Okay, when we do geometric tomorrow, it's going to switch to multiply and divide. So added and subtracted between terms is what we're looking at today. And then our recursive one, you got your a sub 1, is just going to equal whatever number is that first term value. And then you got a sub n is equal to, this here, this a sub n minus 1, that just stands for the previous term. So like whichever number was listed before that is what that value stands for, and that's kind of listed off to the side there, plus whatever that constant difference value is. And then this back part here, all this is saying is when we do this, it's just telling us that we're doing it for like term numbers. So the first term number is already listed there. So you could say like for integers, n is greater than 1, because it's basically all of our values after the first one. We would use this kind of formula here. Sometimes the book will also have it as like n is greater than or equal to 2. For these purposes, those mean the same thing. So it's just saying that you're starting at the second term and going on from that. I don't care which way you write it. Okay, let's take a look at some of these here. Okay, everybody got a new packet, right? Okay, so looking at the first one here, what they do is they give us, it says suppose E is our arithmetic sequence, and then it says E sub 5, or like that would be like our fifth term, is 400, and then E sub 12, our 12th term, is 827, and we're supposed to come up with an explicit formula for this and a recursive formula for this. Okay, so if we're thinking explicit here, for A, we've got to have something that's like A sub n is equal to D, and then n minus 1, plus A sub 1. Okay, so the things that we need here to be able to make this equation, we need to find what that D value is, and we need to figure out what that A sub 1 value is. Okay, to figure out what the D value is, what you do is you actually think of these kind of like ordered pairs. So it's kind of like if we thought of it as an ordered pair, like if we were going to graph it, it would be like n, comma A sub n, n being like our term number, our position, and then A sub n being the thing that gets kicked out. So if I turn these two things into ordered pairs, it would kind of be like 5 and 400, and then the other one 12 and 827. And then what we're doing here when we need to find constant difference is the same as rate of change, which is the same formula as slope. So I'd write that in here just as a note to yourself that D for our constant difference is the same as rate of change. And again, rate of change formula is the same as like the slope formula. So what I can do here is if I need to figure out what my D value is to plug in over here, I can just treat this kind of like a slope and go, okay, well, I got to do y minus y. So my y's on the top would be like 827 minus 400 over, if I pick the 827 first, got to pick 12 first, minus 5. So my 827 minus 400 is 427. And then 12 minus 5 is 7. And then I think that actually divides out nice. 427 divided by 7 actually does, it's 61. So what that tells me then is that 61 can go over, for that D in my formula, so basically this guy can go over there into my formula. So I go like equals 61 there, and we leave it as the A sub n minus 1, and then we just now have to find what that first term is, okay? So to be able to find that first term, what we can actually do is we can plug in that 61 that we just found, and then also plug in like an A sub n and an n from like up here. So what I'm going to do to find this A sub 1, I'm going to take that formula again, put that 61 in there, minus 1, trying to find, my pen's dying, trying to find that first term. And then what I'm going to do is I'm going to take this ordered pair from up here, and you could use either ordered pair, but I'm going to put those into those two spots right there. Okay, so I'm going to put the 5 in for the n, and then I'm going to put the 400 in for the A sub n, because that's just going into that formula. Now that I have everything filled in besides one thing, now I can just solve for what that A sub 1 is. So that would be like 5 minus 1 would be 4, so like 61 times 4, plus that A sub 1, is equal to our 400. 61 times 4 is 244. And then my other stuff will just drop down there. And then to get the A sub 1 by itself, subtract 244 from each side. So then my A sub 1, or my first term, would end up being 156. So then I can take that guy, put that back up here for my A sub 1 that was missing. So 156 would just go into that spot. So this guy is going into that spot right there. Okay, and then that would be all I need. You could leave it like that. Technically you could, and I'll show you this on the next one, you could also distribute that 61 to both things and kind of go down a little bit further. I don't care if it says to, take it down further, you can, but if it doesn't say, you can leave it like that, and that's cool. Okay, so that's that one, and then they want us to do the same thing, except for they want us to find the recursive formula. Oops, too many things there. But recursive formula, we just need the same stuff, so now that we've found that stuff, we can just plug into it. So like the recursive formula is where it's like the A sub 1 is equal to something, and then A sub n is equal to the A sub n minus 1 plus whatever that constant difference is. So we can just take our same info there and put it in the spots. So like we know our A sub 1 was that 156, so we can just go like A sub 1 is 156, and then that second row there, A sub n is equal to that A sub n minus 1 just stays as is for the previous term, And then our constant difference would be our d value that we found up here, which we know that would be the 61. And then again, for the back, I don't care if you do it for like integers, what is it, n is greater than 1, or you can do it as n is greater than or equal to 2. They're, like I said, they're kind of interchangeable. It doesn't matter which one you go with. But that would be that one. So once you find the parts, just plugging it into the spots, basically. Okay, and then the second one I added here, because there's some that they're going to ask on the assignment that have stuff kind of like this, where it's like asking about like banking or changes and that kind of thing. So it says, suppose you got $250 in savings now and can save $70 to $5 a week. We're supposed to turn that into an explicit formula and a recursive formula. So my thought there would be one of these values is probably my constant difference. The other one is like my first term. So our initial condition or our first term would be kind of like our starting amount here. So that 250 is going to be like our a sub 1 for our first term. And then if we're saving $75 a week, that would be like how much we're changing per week. So that'd just be our d value or our constant difference. And then again, you're just plugging into that formula. So like for explicit, it'd be a sub n is equal to our constant difference value is that 75, parentheses, n minus 1, plus our starting amount there for the first term would be 250. And then you could be done at that step. Like I said, you could also simplify this out. So if it said, hey, simplify it or whatever, it looks a little different. You could take and distribute that 75 through there and also write it as, so it would be like 75n minus 75. Maybe I should actually write it. So it would be like 75n minus 75 plus the 250. And then combine your negative 75 and your 250. And it would be like 75n plus 175 is equal to our a sub n. Again, I don't care. The book might ask you like one way or the other, but they're the same exact formula there. Okay, and then recursive, same stuff. So we just go our a sub 1 would be like our first term, so the 250. A sub n would be our previous term, so a sub n minus 1. Our constant difference, there's the 75, and it's positive 75, so plus 75. And then again, that would be for integers. And then again, you could write it as like n is greater than 1 or n is greater than or equal to 2. Either way is fine. Also, you might have noticed that the book writes their formula like backwards of this. I just do it this way because like when they write it, they put like the constant difference at the back, but that seems weird for distributive property, so I just put it at the front. But like I said, they all mean the same thing. Okay, that's it. So get that book page for tomorrow. And then like I said, tomorrow will be the geometric stuff.